factor trinomials of the form x squared plus bx plus c. Hopefully you remember how to use the FOIL method. And so let's say we had the example where we wanted to multiply x plus 2 and x plus 4. We would draw our FOIL lines, first, outer, inner, and last. And we would see that becomes x squared plus 4x plus 2x plus 8. When we combine like terms, that would reduce to x squared plus 6x plus 8. In this section, we want to start with something in this form, in the form of x squared plus 6x plus 8, and factor into the two binomials that must have been used to create it. Essentially, we want to find two numbers whose product is c, or the constant at the end, and simultaneously whose sum is b, the number in front of the middle variable. Because there are fewer choices for the product, we will always start by looking at the factors of c, of the constant. This will always be the form that we factor x squared plus bx plus c into. X squared always factors into x times x, and that's why we fill the first two terms of each binomial with x's. We can see that the empty blanks should be the product that forms c and the sum that forms b. So let's try an example. Let's factor the polynomial x squared plus 13x plus 30. Right away, we know that the first term in each binomial should be x, because x times x is x squared. Now we want to look at 30. We want numbers that will multiply to 30 and simultaneously will add to 13. Now, because 30 is positive and the sum is positive, our two factors must be two positive numbers. So hopefully you remember how to find the factors of a number. You can always take the square root of 30. That would give you the largest number where you would start. This is a process that was outlined in Module 1, Section 1. And if you need extra help, make sure to ask your instructor. So as we start looking at the factors of 30, we have 1 times 30. And we need those two numbers to add up to 13. But 1 and 30 add up to 31. So that's not the group of factors we want to use. We continue to go through the list. 2 times 15 equals 30, but 2 plus 15 is 17. That's not good. As we continue, 30 equals 3 times 10, and 3 plus 10 is 13. So 3 and 10 are the two numbers that satisfy the two conditions we have. So for that reason, we're going to fill in our binomials with a positive 3 and a positive 10. Now, just to make sure that we've actually factored correctly, we can go back and check our work. So here's a nice check step that you can use on a test to see if the answer you're about to put in is a correct answer. We use the FOIL method, and if the result is the problem we started with, then we worked it correctly. So we draw our FOIL lines, first, outer, inner, last. The first is x squared, outer is 10x, inner is 3x, last is 30. We combine our like terms, and this becomes x squared plus 13x plus 30, which is exactly where we started. So we know we factored correctly, and x plus 3 times x plus 10 is the answer. Let's try another example. Again, because our leading term is x squared, and the only way we can break down x squared is x times x, those will be the first two terms in our binomials. Now we go back up to the problem, and we see that we want two numbers that will multiply to give us 24, but that will add to give us negative 11. Now, the only way we can have two numbers multiply to make a positive number, but add to make a negative number, is if both of those numbers are negative. So as we're finding factors of 24, each factor needs to be negative. So we start with 1 and 24, and remember, if this is going to work, they will both have to be negative. But negative 1 plus negative 24 is negative 25. Those don't add up to negative 11. So we continue to go through the list. 2 times 12, we make each of these terms, each of these factors negative. But negative 2 plus negative 12 is negative 14. We're closer, but we still haven't arrived at the number we want. So we continue to find factors of 24, negative 3 and negative 8. And negative 3 plus negative 8 is negative 11. So negative 3 and negative 8 are exactly the two numbers we want to complete our binomials. And just like last time, we could do our check step and find that this is exactly what the answer should be. Let's try another example. Let's factor the polynomial x squared minus 2x minus 35. Because we start with the x squared factors into x times x. We know the first terms of each binomial. We go back to the original polynomial and see that we want numbers that multiply to give us negative 35, but that add to give us negative 2. Now in this example, the only way we can have a product that is negative is if one of our factors is positive and one of our factors is negative. At the same time, when you have a positive and a negative number being added together, the only way that sum can be negative is if the larger quantity is a negative value. The larger absolute value is negative. So remember, as we find factors of negative 35, we want one to be positive and one to be negative, and the number whose distance is furthest from 0 should be the negative value. So we start looking at factors of 35. We have 1 times 35. 35 is furthest from 0, so it gets the negative sign. 1 plus negative 35 is negative 34, not even close to what we want, which is negative 2. As we think of more factors of 35, 35 ends in 5, so 5 is a factor. 5 times 7, 7 is furthest from 0, so it gets the negative sign. 5 plus negative 7 is negative 2. That's exactly what we want. So a positive 5 and a negative 7 will be used to fill in the binomials. And let me mention now that it doesn't matter the order in which the binomials are written. The only thing that matters is you have the correct numbers written with the correct signs. You can't flip-flop your signs. Here we have another example. Let's factor x squared minus 6x plus 10. We know that if this is going to factor, x squared equals x times x, so we have the first terms of each binomial. We then go back to the polynomial and find we want two numbers that multiply to give us 10, but that add to give us negative 6. Now remember, the only way we can get two numbers to multiply and be positive, but to add and be negative, is if those two factors are negative. So let's find the factors of 10. We have 1 and 10, and each needs to be negative. Negative 1 plus negative 10 is negative 11. We also have 2 times 5. Each of these factors need to be negative. Negative 2 plus negative 5 is negative 7. And neither of these pairs of factors gave us the sum that we wanted, and 10 has no more integer factors. So because we have no factors that satisfy both conditions, we would say that this polynomial is prime. And if a polynomial is prime, that means it has no factorization using integer numbers. You should always check your factoring, as we have in a few examples, by multiplying the factored polynomial to verify that it is equal to the original. This is especially helpful on tests. Many times you can detect computational errors or errors in the signs of your numbers by simply checking your results. And it doesn't take that long. Let's try a few more examples. Here we have x squared plus 5xy plus 6y squared. It's okay that we've introduced another variable. Look at how we're going to take care of it. We know that x squared is x times x. We know we have to fill in a number using the two conditions with the 6 and the 5. But with that number, the only way we can get y squared is y times y. So we go ahead and fill in our variables before we ever start, and then we follow the same process that we have. We want two numbers that multiply to 6, but that add to 5. As we go through the factors of 6, 1 times 6 is 6, 1 plus 6 is 7. 2 times 3 is 6, and 2 plus 3 is 5. So 2 and 3 are exactly the numbers we want. So we use those numbers to fill in the blanks. I'll just rewrite it. X plus 2y and x plus 3y. Now let's factor x to the 4th plus 5x squared plus 6. Because we don't have x squared, we know it can't be x times x, because x times x is x squared, not x to the 4th. To get x to the 4th, we have a few different combinations. It could be x to the 4th times 1, or x cubed times x, or x squared times x squared. So we look at the middle term, and that helps us decide which combination we're going to use. I need two factors that will multiply to give me x to the 4th, but when I add different coefficients, it's going to be x squared. So we're going to use x squared and x squared for our variables. And many times, if you don't have just x squared up front, you can look at the middle term to decide how you're going to break down that variable. So now that we've decided that variables are x squared and x squared, we go through the process like normal. We want to multiply to get 6, but add to get 5. And just like in the last example, 2 times 3 equals 6. 2 plus 3 equals 5. So 2 and 3 are the two numbers we will use to complete each binomial. In this example, we have 3m squared minus 24m minus 60. And we see that in front of m squared isn't just the number 1. We have a 3. This is the first time we've seen it, but it's always important to at least try to factor the GCF, the greatest common factor, before we use the factoring methods learned in this section. So if we go through the process that was laid out in section 1, we find the GCF is 3, and the resulting polynomial would be m squared minus 8m minus 20. So before we start factoring, we know the first two terms in each binomial will be m's, because m times m is m squared. So now we use the negative 20 and the negative 8 to determine how to fill in the missing pieces. We want two numbers that multiply to give us negative 20, but that add to give us negative 8. Remember, the only time we can have a product that is negative is if we have one positive factor and one negative factor. The only time we can have a sum that is negative when we have one positive factor and one negative factor is if the negative number is larger. So remember that as we're finding our list of factors, we need one positive and one negative. The negative quantity needs to be larger in absolute value than the positive. So we start with the factors of 20. 1 times 20. 20 is furthest from 0, so it gets the negative. That gives us negative 19. That's not good. We also have 2 times 10. 10 is furthest from 0, so it gets the negative. 2 plus negative 10 is negative 8. That's exactly what we want. So we fill in the gaps with a positive 2 or plus 2 and a negative 10, minus 10. Let me show you an example of what it looks like when we check our work if we have a greatest common factor. So we start by just writing down our answer. We're going to distribute the greatest common factor into the first set of parentheses. That will give us 3m plus 6 times m minus 10. And at this point, we use the FOIL method. First, outer, inner, and last. And this becomes 3m squared minus 30m plus 6m minus 60. We combine our like terms, and we're left with 3m squared minus 24m minus 60, which is exactly where we started at the beginning of the problem. So we know that our factorization was good. Here's another example that will require factoring the GCF. We have 2x to the fourth minus 26x cubed plus 84x squared. So always, if possible, we factor the GCF. Using the same process we did in the last example, and that was thoroughly explained in Module 6, Section 1. We factor 2x squared, and the resulting polynomial is x squared minus 13x plus 42. We go a little bit further, and we know that x squared factors into x times x. And now we use the 42 and negative 13 to find the missing pieces. We need numbers that will multiply to 42, but that will add to negative 13. Now, the only way this can happen when we have two numbers that multiply to a positive but that add to a negative is if each factor is a negative number. So let's be mindful of that as we find the factors. Start with 1 and 42, and those each need to be negative. That would add up to negative 43. It's not what we want. We then go to 2 and 21. Each number is negative. Those add up to negative 23. We're closer, but still not there. We also have 3 and 14. Each of those numbers are negative. It gives us negative 17. We're even closer to the negative 13 now, but not quite what we want. Let's try 6 and 7. Again, each of these factors must be negative. Negative 6 plus negative 7 is negative 13. So these are exactly the two factors we want to use to fill in the missing pieces of each binomial. And just like the last example, we could check ourselves. We start by distributing the GCF to the first binomial and then FOILing. More examples. Here we have u squared plus 16u plus 21. Well, we know the only way we could get u squared is u times u. Let's use the numbers 21 and 16 to try to fill in the rest. So we want to multiply to get 21 and add to get 16. And the multiples of 21, the factors of 21, 1 times 21, those would add to 22. That's not good. We also have 3 times 7. Those would add to 10. That's not good. And we have run out of factors, at least integer factors. So we have no factors that will satisfy both conditions. We would say that this polynomial is prime. Let's try an example where we have fractions. So we want to factor 1/4 y squared minus 3/4 y minus 10. A hint for a problem that is leading with a fraction. Let's factor that fraction. So we want to factor out 1/4. We'll say 1/4 is our GCF in this problem. Now remember, when we factored out a GCF, it was the same thing as dividing all of the original terms by that number. But when we divide by a fraction, if I divide by 1/4, that's the same thing as multiplying by 4. So let's rewrite this where we're multiplying every term by 4. Our resulting polynomial now becomes, we have 1/4 times. 4 times 1/4 is 1, so y squared minus 4 times 3/4 is 3, minus 3y, and 4 times 10 is 40, minus 40. We know that the trinomial will break down into two binomials. Y squared is y times y. Let's use the 3 and 40 to find the missing pieces. So we want two numbers that multiply to -40, but that add to -3. So as you go through, and I'm not going to list every factor this time, hopefully you're comfortable with finding a list of factors at this point. We do know that the product is negative, so one number must be negative, one number must be positive, and the larger number, indicated by the sum, must be negative. So we try 5 times 8, the larger number is 8, so it's going to get the negative sign. 5 plus -8 is -3, so these are exactly the two numbers that will fill in our binomials. And here we have the factored result.